Database engineers are vital to building and maintaining data systems that support reliable, fast, and secure access to information. As businesses increasingly rely on data-driven strategies, the demand for database professionals has grown significantly. To succeed in an interview, candidates must demonstrate a strong grasp of core database concepts, architecture, and best practices. Below are the top 20 interview questions and answers designed to help you confidently prepare for your next opportunity. 1. What is normalization and why is it important? Normalization organizes data to reduce redundancy and improve integrity by splitting large tables into related ones and using keys to connect them. It follows several normal forms, 1NF, 2NF, 3NF, etc., to remove duplication and ensure consistency. This structure makes updates more efficient and reduces anomalies. However, over-normalization can lead to complex joins, so a balance must be maintained between normalized data and system performance requirements. 2. Explain ACID properties in database systems. ACID stands for atomicity, consistency, isolation, and durability. These properties ensure reliable transaction processing. Atomicity guarantees that all operations in a transaction complete or none do. Consistency ensures database validity is maintained. Isolation keeps transactions independent from each other. Durability ensures completed transactions remain even after system failures. Together, they ensure data accuracy, prevent corruption, and maintain trust in a database system's integrity under various conditions and failures. 3. What is indexing and how does it improve performance? Indexing creates a data structure that improves the speed of data retrieval operations on a database table. It works similarly to an index in a book, allowing the engine to locate rows faster without scanning the entire table. While indexes speed up select queries, they can slow down insert, update, and delete operations due to additional maintenance. Choosing the right fields to index is key to optimizing performance effectively. 4. What are clustered and non-clustered indexes? A clustered index dictates the physical order of data in a table, and only one can exist per table. It stores data rows directly within the index structure. A non-clustered index stores a separate structure from the data and includes pointers to the actual data rows. Non-clustered indexes can be created multiple times on a table. Clustered indexes are great for range-based queries, while non-clustered ones are ideal for lookups. 5. How do you ensure database security? Database security involves safeguarding data against unauthorized access, tampering, and breaches. Best practices include implementing strong authentication and access control mechanisms, encrypting data both in transit and at rest, conducting regular security audits, and applying timely patches and updates. Role-based access control ensures users can only access data relevant to their responsibilities. Additionally, database activity monitoring tools help detect and respond to suspicious behavior in real time. 6. What is a stored procedure? A stored procedure is a set of precompiled SQL statements stored within the database. It allows reuse of common operations like insertions, updates, or complex calculations. Benefits include improved performance through planned caching, reduced network traffic, and enhanced security since users can execute procedures without direct table access. Stored procedures also support parameters and conditional logic, making them ideal for enforcing business rules and maintaining consistent data manipulation operations. 7. Describe the difference between OLTP and OLAP. OLTP, online transaction processing, systems handle real-time transactional data. They focus on short, frequent operations like inserts and updates. OLAP, online analytical processing, systems are used for complex queries, trend analysis, and reporting on large historical datasets. OLTP prioritizes speed and consistency, while OLAP emphasizes query performance and data summarization. The design of databases for OLTP is normalized for speed, whereas OLAP databases are denormalized for efficient querying. 8. How do you handle schema changes in production? Schema changes in production are handled cautiously to avoid service disruption. Changes are first tested in staging environments. Version control systems track schema modifications. Zero downtime techniques, like rolling updates, blue-green deployments, or feature toggles, are preferred. Proper backups are taken before applying changes. Communication with teams and rollback plans ensure readiness for issues. Tools like Liquibase or Flyway help automate and manage migrations safely and systematically. 9. What is a database transaction? A database transaction is a sequence of operations executed as a single logical unit of work. It must follow the ACID properties: atomicity, consistency, isolation, and durability. Transactions are essential for maintaining data integrity, especially in multi-user environments. They begin with a begin statement and conclude with either a commit or rollback, depending on whether all operations succeed. They are commonly used in financial, booking, and e-commerce systems. 10. What is denormalization and when is it used? Denormalization is a process of introducing redundancy into a database by merging tables or duplicating data. It improves read performance by reducing the number of joins in complex queries. This is particularly useful in reporting or analytical systems where speed outweighs strict data integrity. However, denormalization can lead to anomalies and increased storage usage, so it's applied selectively and strategically to balance performance and maintainability. 11. How do you optimize SQL queries? SQL query optimization involves improving performance without changing results. Common techniques include using proper indexes, avoiding select, filtering early with where clauses, analyzing execution plans, reducing nested subqueries, and using JOINs appropriately. Updating statistics and ensuring the database engine has current information also helps. Query optimizers may benefit from hints or restructuring queries. Regular monitoring and profiling help identify and address bottlenecks in query execution. 12. What is the difference between a primary key and a unique key? A primary key uniquely identifies each row in a table and cannot contain null values. A table can have only one primary key. A unique key also enforces uniqueness of values but allows one null, depending on DBMS. A table can have multiple unique keys. Both keys help maintain data integrity, but the primary key is the main identifier, often referenced by foreign keys in other tables. 13. What are foreign keys and why are they important? A foreign key is a field, or combination of fields, in one table that establishes a link to the primary key in another. It ensures referential integrity by restricting the actions that would lead to orphan records or inconsistent relationships. For example, deleting a parent record referenced by child records can be restricted. Foreign keys help maintain structured and reliable data relationships across relational databases. 14. How do you monitor database performance? Database performance is monitored using tools that track metrics like CPU usage, memory, disk I/O, query response time, and connection counts. Tools like Oracle Enterprise Manager, SQL Server Profiler, pgadmin, and third-party services like New Relic or Datadog are commonly used. Query logs and execution plans help identify slow queries. Proactive monitoring enables capacity planning, early detection of issues, and performance tuning to ensure optimal system operation. 15. What is a deadlock and how do you resolve it? A deadlock occurs when two or more transactions block each other by holding resources the others need. It halts progress until intervention. Most DBMS detect and resolve deadlocks automatically by aborting one transaction. To prevent deadlocks, developers can access resources in a consistent order, keep transactions short, and use proper isolation levels. Monitoring tools also help identify and analyze recurring deadlocks for long-term resolution. 16. Explain different types of joins in SQL. Joins combine rows from two or more tables based on a related column. Inner join returns matching rows. A left join returns all rows from the left table and matched rows from the right. Right join does a reverse. A full outer join returns all rows when there's a match in either table. Cross join returns a Cartesian product. Joins are fundamental for relational queries and data aggregation. 17. What is partitioning in databases? Partitioning divides a table into smaller, more manageable parts without changing its logical structure. It improves performance, manageability, and scalability. Common types include range, list, hash, and composite partitioning. Partitioning is particularly useful for large datasets, as it allows queries to access only relevant partitions. Maintenance operations like backups and indexing can also be more efficient on partition tables, making it a crucial technique in large-scale systems. 18. How do you manage database backups? Database backups are managed using full, differential, and transaction log backups, scheduled based on recovery objectives. Backups can be stored locally, off-site, or in the cloud. Automation tools handle backup scheduling and integrity verification. Engineers regularly test restore procedures to ensure reliability. Snapshot-based backups, replication, and point-in-time recovery techniques provide additional flexibility. A strong backup strategy is essential to disaster recovery and business continuity planning. 19. What is sharding and when is it used? Sharding is a database scaling technique where data is horizontally partitioned across multiple servers or nodes. Each shard holds a subset of the data, often based on a sharding key like user ID. It is used when a single server cannot handle the volume of data or query load. Sharding increases performance and availability but introduces complexity in data consistency, query processing, and schema management. 20. How do you stay updated with database technologies? Staying updated involves regularly reading official documentation, following database blogs, attending webinars and conferences, and participating in developer communities like Stack Overflow or Reddit. Online platforms such as Coursera, Udemy, and YouTube offer courses on emerging tools. Following updates from major database vendors like Oracle, Microsoft, PostgreSQL, and MongoDB also helps. Joining professional groups and contributing to open-source projects can further deepen understanding and exposure. Mastering the technical and conceptual elements of database engineering is essential for excelling in interviews. The questions above span foundational principles, system design, performance optimization, and real-world application scenarios. Use them to sharpen your skills, reflect on past projects, and prepare relevant examples. With focused preparation and clear communication, you'll be well equipped to demonstrate your expertise and stand out as a strong candidate in any database engineering role.